Alright, so in this video we'll go over the hypotenuse-leg theorem, and then we'll show an example of a written proof where we're going to use the theorem to prove that the triangles are congruent. The first thing we have to really specify is that the hypotenuse-leg theorem only works for right triangles. So the first thing we need to prove is that the triangles are right triangles. Once we have that, then we could use the hypotenuse-leg theorem. The hypotenuse-leg theorem says if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. And like I said before, the HL theorem only applies to right triangles. So the first thing we need to do is prove the triangles to be right triangles before anything else. For this little example I have here, we see that the given says that angle B and angle F are right triangles. And we specify if a triangle is a right triangle by including this little symbol right here, which I'll mark up. I could circle it. This symbol right here means a right angle, this right here. Alright. AC, segment AC is congruent to ED. That would be our hypotenuse. So the hypotenuse is the segment which is opposite the right angle. That is the hypotenuse. So we can see that both those hypotenuse of the two triangles are congruent with the two hash marks, and it says that segment AB is congruent to FD. So I'll mark that up also, which is right here. We call that a leg. So a right triangle has two legs. That is one of the legs, and we display that there. So since we have a hypotenuse which is congruent to another hypotenuse and a leg which is congruent to another leg, and both triangles are right triangles specified by the right angle symbol, we could then say that these two triangles are congruent because of the hypotenuse-leg theorem. Alright, so now let's use this theorem in a proof. So here we have a proof, and we are given that segment WJ is congruent to segment KZ. So let's mark that up on our figure first. So we have WJ, which is right here, is congruent to segment KZ, which is right here. Okay, and we see that angle W and angle K are right angles. So let's put that mark in there, right there. Okay. So since we are told that we have right angles, then these two triangles have to be right triangles. But we have to prove that, and we have to specify that in our statement and reason format for this proof. Ultimately, we want to prove that triangle JWZ is congruent to triangle ZKJ. And we can see that there's two triangles here. It's kind of like a rectangle with a diagonal, which forms two triangles, a upper triangle and a lower triangle. And I'll just label that really quick. This would be triangle number 1, and this would be triangle number 2. So how can we prove that these two triangles are indeed congruent? Well, we have to start with one of our givens. So let's start with one of our givens. Let's start with angle W and angle K are right angles. Now, why would I want to start with that? Well, we said that in order to use the hypotenuse-leg theorem, we have to have right triangles. So this would be a good place to start. So angle W and angle K are right angles, and the reason is it was given. We were told that these two angles were right angles. So now, since we have right angles, we can now say that triangle JWZ and triangle ZKJ are right triangles. Now, what does that do for us? Well, like I said before, we can only use the HL theorem when we have right triangles. So to prove that these two triangles are indeed right triangles will allow us to use that theorem later on to prove that the triangles are congruent. So what is the reason that these two triangles are right triangles? Well, that's the definition of right triangles. So we can put definition of right triangles. Okay, right triangles have right angles, and we know that we have right angles because they were given. So definition of right triangles is the reason for that statement. All right, now after we have that, we can look at what else we have, and we have that WJ, segment WJ, is congruent to segment KZ. And the reason for that is it was given. So, all right, given. All right, and now let's look at what we have. Well, we have a leg of a triangle, specifically a right triangle, because we already proved that these two triangles are right. So what do we need in order to prove these triangles are congruent? Well, we could use the hypotenuse-leg theorem. But the hypotenuse-leg theorem says that we need an hypotenuse and a leg of one triangle. And if that is congruent to an hypotenuse and a leg of another triangle, then both those triangles are congruent. So we can see that the diagonal is actually a shared segment. And I'll write that segment here. That segment is JZ. Segment JZ. Now, what do we know about segment JZ? Well, segment JZ is shared between both triangles. So let me just highlight segment JZ, which is right there. That segment is shared between both triangles. So if it's shared between both triangles, it is one and the same. So we can say that segment JZ is congruent to segment JZ because they are the same segment. And we can mark it up in our figure with 2 hash marks to say that they are congruent. And the reason is we know the reflexive property. So we can put reflexive property. Now, since we have just proven that this segment is congruent, and we were given that another segment, 2 segments, which were the legs of the triangle, are congruent, and we know that the triangles are right angles, we can now say that triangle JWZ is congruent to triangle ZKJ because of the HL theorem. And we have now proven what we set out to prove.